Well, hello. This is the fourth video of the night. I should have the whole four sections that we'll probably hit again after chapter 9 because it's probability with it. So chapter 9 has some probability stuff a little bit, not really. In any case, or chapter 12 does. Chapter 12 has a probability. So we'll do it after chapter 12. Explore solids. I can identify solids. These are learning targets, and I can apply these area problems in real life situations. Now, I don't know if you recall having a bunch of shapes kind of like this, or actually more like this. There's solids, and I have it in a box in the classroom. These are called platonic solids. There are only 5 regular polyhedrons. So here we go. Let's look at some of these problems, and then you can understand the vocabulary I just used. All right, name a polygon by the number of sides. 6 sides is a hexagon. 10 sides, deca, like decade, decagon. 5 sides, pentagon. That should be review. Of course, I probably will cover this section before. What is a regular polygon? All congruent sides and congruent angles. What is the length of the diagonal of a square with a side length 6? Alright, so that's my square. So remember x square root of 2. So if x is equal to 6, the diagonal is equal to 6 square root of 2. Okay, so it's our special right triangle, x square root of 2. Polyhedron. Okay, notice it's not polygon. Polygon was like a flat figure, 2-dimensional. Polyhedron is 3-dimensional. So it's a solid that is bounded by polygons called faces. All right, so if we look at this like, say it's a Kleenex box, we have 6 different faces. Top, bottom, front, back, left, and right. So an edge of a polygon is a line segment formed by the intersection of 2 faces. So if you look, this right here is an edge, okay? And a vertex of a polygon is a point where 3 or more edges meet. So here's a vertex. And if you'll notice, on this rectangular prism, how many vertexes do I have? And we have one back here hidden. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? It's going to be important because we're going to have to count those. You're going to count edges, faces, and vertexes. Alright, so here are some different polyhedrons. This is a cube, when all sides are squares. This is a rectangular prism. So if the side is a rectangle and you like stretch it out, here's a triangular pyramid. The base is a triangle and all the corners go to a point. These are hard to draw. Usually I just try to draw a triangle and then bring them all up to some point. Now, these are not polyhedras because they have curved sides. A cylinder, kind of like a can, a cone, and a sphere. So, of the solids above, the cube, prism, and the pyramid are polyhedra. To name a pyramid or a prism, use the shape of the base. So, for instance, if I have a triangle and I stretch it out, that's going to be a triangular prism. Notice if I have a triangular base and they all go to a point, that's a triangular pyramid. So, tell whether the solid is a polyhedron. If it is, name it and find the number of faces, edges, and vertices. Alright, so if I take this rectangle and stretch it out, it's a rectangular prism. So how many faces does it have? The right, left, top, bottom, front, and back. So that would be 6. How many edges? 1, 2, let me do the vertical edges first. 1, 2, 3, 4, then the horizontal. 5, 6, 7, 8. Then 9, 10, 11, 12. Thought I forgot some. So edges equal 12. And then the vertices. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's going to be a pattern. I hope you see it. Okay, how about this? If we take this base, how many sides are in the base? 1, 2, 3, 4, 5, 6. So this is my base, and then stretch it up. The base is a hexagon, and when you stretch it up, it's a prism. It's a hexagonal prism. So how many faces? All right, so we have a top and bottom, so that's 2. And then how many sides do we have? 1, 2, 3, 4, 5, 6. So it's a total of 8 faces. All right, how many edges? Okay, I'm going to do the vertical ones. 1, 2, 3, 4, 5, 6. And then I'll do the ones in the bottom. 7, 8, 9, 10, 11, 12. And the ones on the top. 13, 14, 15, 16, 17, 18. And then, how many vertices? I have 6 on the bottom, 6 on top. Rectangular prism. Okay, how do I, sorry, not a prism, pyramid. The base is a rectangle, we don't know if it's a square, okay? And then they all go to a point. Alright, so how many faces do I have? You have the bottom and then 4 sides. How about how many edges? 1, 2, 3, 4, 5, 6, 7, 8. And vertices? I have 4 on the bottom, 1 at the top. And how about this? Not a polyhedron. It's got a curved surface. Alright, so that takes a little bit of counting, but it's not too hard to do. Okay, making sure I'm still recording. Oh, look at this. Euler's theorem. The number, remember that letter E, which is about 2.71828, kind of like pi. Okay, I never remember more than that. In any case, Euler did lots of stuff. Here's another one. The number of faces, vertices, and edges of a polyhedron are related to this formula. F plus V is equal to E plus 2. Let's see if that works. Look at this. F plus V, that's 14, is equal to E plus 2. F plus V is 20 equals to E plus 2. F plus V is equal to 10 equals E plus 2. Hey, well, how about that? So, let's look at this one. It says find the number of edges. I guess we can easily count. There's 4 in the top, 4 in the bottom. Faces. There's 4 in the top, 4 in the bottom. And the vertices, there's 6. So I have F plus V is equal to E plus 2. So 8 plus 6 is equal to E plus 2. 14 is equal to E plus 2. Subtract 2 on both sides. E is equal to 12. And go ahead and count them. See if it works. Alright. Polyhedron is regular if all of its faces are congruent, regular polygons. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. If the segment goes outside the polyhedron, then the polyhedron is non-convex or concave. So here are the only 5 regular polyhedron. Triangular pyramid, the cube, octahedron, that's the shape we had right here, icosahedron, and a dodecahedron. Okay, how many sides do these two have? So here we go. Past those platonic solids, let's go to example 3. Find your number of faces, vertices, and edges of the regular dodecahedron. Check your answer using Euler's theorem. Alright, so faces. Okay, this one's going to be tough. Let's see here. 1, 2, good luck with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I get 12. Double check. Vertices, these are easier. 2, 3, 4, 5, 7, 8, 9, 10, 13, 14, 15, 17, 18, 19, 20. Verse equal 20, and then the number of edges. Those are how many lines you have. So it's easiest to do this with a colored pencil and count through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. All right, edges is equal to 30, so double check. Remember, faces plus vertices is equal to edges plus 2. So 12 plus 20, does that equal to 30 plus 2? Yes. All right. So how many sides are in a dodecahedron? 12. Okay. All right. Let's move on. Describe the shape formed by the intersection. So basically, let's say I have a cylinder here, and I'm going to cut it in half with this cardboard, and this is the shape you're going to get. You're going to get a rectangle. If I cut going straight across this way, you're going to get a circle. And if I cut on a diagonal, you're going to get like an oval. But we do know, mathematically, this is called an ellipse. So here are famous cross sections. These are called conic sections. I would like to go over conic sections a little bit with you if we finish our whole book before the end of the year, so we might have like a week of this. Of course, you have two cones, one above the other. If you cut it going across, you get a circle. Cut it a diagonal, you have to see this parabola. If you cut it right here, you'll get an ellipse. And if you cut straight up and down, you'll get a parabola this way and a parabola upside down this way. They call it a hyperbola. All right, some more polyhedrons. They must have flat faces. Here are some examples. Non-polyhedrons have round surfaces. That's called a torus. Here is our homework. There's our Common Core standard. So nice, easy section. The next couple sections are about volumes and surface area of all of these shapes. So everybody have a very nice evening. Take care.